In this video, I'd like to talk about the area of a trapezoid. Specifically, I want to show you the formula for finding the area of a trapezoid and how we can derive that formula, so how we can actually get that formula. So remember the definition of a trapezoid. It's a four-sided figure, or a quadrilateral, that has one pair of opposite parallel sides. So this side right here and this side right here, these are parallel to each other. So with a trapezoid, we will generally call the parallel sides the bases. So we can call this base 1, and I'll write that out explicitly, base 1, and we can call this base 2, or b sub 2. And we also need to know the height of this trapezoid to find its area. So let me draw in a vertical line, and you can draw this from any point on this base downward, but we're going to split this into a triangle anyways. So this will be at a right angle. It's going to be perpendicular to these parallel lines, and we can call this h for the height of our trapezoid. And the formula, I'll just write down the area of this trapezoid, will be that height, h, multiplied by the average of the bases. So b1 plus b2 divided by 2. Since remember, when you're finding the average of something, you add them together and then divide it by 2. So if we're finding the average of 10 and 20, we know the average number is 15, since that's right in the middle of these. But a mathematical way to find it when the numbers are more difficult is to add them together and divide by 2, since this is 30 over 2, which is 15. So that's the general process of finding the average. And we're finding the average because we essentially want the middle of the two bases. And the general idea of finding this average is that we want to transform this trapezoid into a rectangle, since finding the area of a rectangle is fairly straightforward. So we could find the average of the bases, which would be right in the middle of our two bases. And we can draw perpendicular lines to split up our shape. Let me redraw that one. And by doing this, we can essentially take this bottom triangle and rotate it up here. And we would do the same over here, where we would take, again, this bottom triangle and rotate it up here. And then notice we'd have a rectangle where the base is that average value of the two bases, and the height we would know. So this formula could be thought of as a transformation of this trapezoid into a rectangle. So that's one way to approach it. Another way to approach it is to decompose this trapezoid into two different triangles and a rectangle in the middle. So let's take that approach. So I'm also going to drop a perpendicular line here so that we get another triangle here. And instead of calling this base 2, we're going to split this up into three different sections. So first of all, this is a rectangle in the middle, which means that the opposite sides are going to be equal. So this is base 1 here. And let me use a different color so that we know that it's not the same here. So this would be base 1. And we can call this base of this smaller triangle, let's just call it A. And this base of the bigger triangle, we can call that C. So the area of the trapezoid, we could split up into these three different pieces. We can call this A, we can call this B, and we can call this C. So just like with composite shapes, we break them up into smaller shapes and then find the area of each of those and add it together. So remember the area of a triangle. Let me make just a little bit of room so that we have some space to do this. But the area of a triangle is half the base multiplied by the height. So for A, it would be half of A multiplied by H. The area of the rectangle is just the length times the width, or the base times the height, depending how you want to think about it. So this width is B1, and the height is H. And then the area of this other triangle here, this C triangle, we take half the base, which we called C, and multiply it by the height, which is still h. So this would also have height h because this is a rectangle, so opposite sides are equal. Now we could rearrange this a little bit. So what I want to do is, first of all, factor out a 1/2. So from all of these, I'm going to pull out 1/2. And from here, we would have a times h. From here, pulling out a half, we're going to be left with 2b1 times h. Since if you think about it, when we redistribute, 1/2 times 2 would cancel out, and we'd get back to 1 there. So, or in other words, when we're factoring, we're dividing by what we're factoring by. So we're dividing this by a half, which is the same as multiplying by 2. And here we're pulling out the 1/2, so we're left with c times h. And we'll continue by noticing that all of these have h in them. So we can pull that out as well. And we would then have 1/2 h multiplied by a plus twice b1. And I'll rewrite that as b1 plus c. And what we can do next is separate out one of these b1s. So let me rewrite that, where now this is 1/2 h multiplied by b1 plus a plus b1 plus c. And the reason we pulled one of the b1s out is now we can notice this sum right here is b2. Since when we split up this shape into 3 smaller shapes, we split up the second base into these 3 pieces. Piece A, piece B1, and piece C. But if we added them all back together, they are just equal to B2. So we can substitute that back in so that now, let me just make a little more room. This is equal to H multiplied by B1 plus B2, and we can move the 1/2 back on the inside. So this would be divided by 2. And notice that's the exact formula that I claimed it would be. So this is just a way to prove to yourself that this formula does make sense. This is how we would derive the formula, where we get the formula from using just basic principles, breaking this shape up into 3 smaller shapes and then adding up the area and just rearranging the equation to find an easier way to look at it. So in conclusion, the area of this trapezoid is the height multiplied by the bases added together divided by 2. Or in other words, it's the height multiplied by the average of our bases.